So we're going to be covering inverse functions right here. And here's the main part of the notes. To find the inverse of a function, switch the x and y and then solve for y. Okay, it's that simple. To find the inverse of a function, switch x and y and solve for y. That's what we're going to be doing today. You're going to be switching the x and the y and you're going to be solving for y. Now, this is just inverse notation for f of x. F of x is just a function, and if you ever see f to the negative 1 power of x, that's just saying to find the inverse, okay? And then, another very important fact on this section, if you take the inverse of a function and plug it into the original function, then the answer will be x. After you do the math, the answer is going to be x. So remember, here's a notation for inverse. So if you did take f of x, switched x and y, solved for y, and you take your new inverse function and plug it back into your original function, everything cancels out except for x. It's kind of weird. So if you ever wanted to verify whether two functions are inverse functions of each other, you simply plug them into each other and everything should cancel out except for x. So that brings us to this last fact right here on this section. To verify f of x and g of x are inverse functions of each other, simply do both. Plug in g of x into f of x. That's the notation. And then plug in f of x into g of x. And both should equal just x. Okay? So let's take a look at this first part. It says practice. Find an equation for the inverse relation. So right here we have f of x equals x plus 4, and we want to find the inverse of it. So it's kind of like this is the notation. So this is saying that we're going to find the inverse of it, and right here I just I wrote it, instead of f of x, I wrote it as y. Okay, so anyways, how do we find the inverse of something? You switch x and y and then solve for y. Okay, so instead of y equals x plus 4, we're going to have x equals y plus 4. So what have we done right there? We've just switched x and y, and then we're going to solve for y. So when we solve for y, you want to get y by itself. You don't want this plus 4. So let's get rid of that plus 4 by subtracting 4 and subtracting 4. So you're going to have x minus 4 equals y. And ladies and gentlemen, that is the inverse of the original y equals x plus 4. Okay, so if you wanted to use the inverse notation, it says f to the negative 1 of x. Well, you would just write down x minus 4 right there. That's your inverse function of f of x. Cool? Now, another fact that that we talked about on our notes was that if you do plug in your inverse into your original, you're going to get x. And that's a way to verify whether your inverse functions are truly inverses of each other. If you plug in the inverse function into your original function, you should just get x. So right here we just did the work, and we already know the inverse function. So this is the inverse function, or this is the inverse function. If we were to take the inverse function and plug it into the original function, we should just get x. So what I want to do is I want to rewrite this guy, y equals, but instead of x, I want to put parentheses and then plus 4. And what am I going to do? I'm going to plug in the inverse function, the x minus 4 part of it, that's the inverse function. I'm going to plug it in right into those parentheses, and I will get x minus 4. And if I simplify it, there's nothing to distribute, so I don't even need to worry about the parentheses. But if I simplify it, the minus 4 and the plus 4 cancel out, and we truly just get x. So there's an example of how to find the inverse And then once you have the inverse, you could plug in the inverse into your original f of x function, and you will see that it just cancels everything out and you have x left over. So so we already did number 1, f of x equaling x plus 4 and finding the inverse. So let's do number 2 together right now, everybody. So I want to find the inverse. What do? Switch x and y. So instead of y equals, I have x equals minus 3y plus 1. You just magically switch them. Switch x and y. And then after you switch x and y, you solve for y. So you want to get y by itself. You don't want the plus 1. You don't want the multiplication of negative 3. So we're going to solve for y now. Subtract 1 here. That'll cancel out. Subtract 1 over here. You're going to have x minus 1 equals negative 3y. Now we still need to get y by itself. So what do? Divide everything by negative 3. Divide this by negative 3. And we're done. We have y equals x minus 1 divided by negative 3. And ladies and gentlemen, this is the inverse function of the original. If I were to take this fraction right here, x minus 1 divided by negative 3, and plug it into here, into the x value, it truly will cancel everything out except x, and I'll have x as an answer. Now they're not asking us to do this right now. All they're asking us to do is to find the inverse. And how do you find the inverse? You switch x and y and solve for y. Let's try number 3. So on number 3, we're going to switch x and y. Instead of y equals, we're going to have x equals. Everything else is the same, negative 2/3, but instead of x, we're going to have a y plus 5/3. So we switched x and y. Now we're going to solve for y. So I want to get y by itself. And I have fractions here. I don't like fractions. If I wanted to, I could get rid of the fractions by multiplying everything by 3. So I'm going to multiply everything by 3. This by 3, the fraction by 3, and this by 3. The 3's will cancel, no more fractions, and I will get 3x on the left side. 3x equals negative 2y plus 5. So I almost have y by itself. I need 2 more steps. I'm going to now subtract 5. Subtract 5. So I will have 3x minus 5 equals negative 2y. And for my final step here, I'm going to divide by negative 2 and divide everything by negative 2. So I will have my final answer. Y equals 3x minus 5 divided by negative 2. And that is the inverse function of the above original. Once again, if I were to plug in this fraction, 3x minus 5 divided by negative 2, if I were to plug it in right here into the x spot, believe it or not, everything would cancel out except just x. So, down here, they're asking us to verify that on number 4, f of x and g of x are inverse functions of each other. And on our notes, it tells us, how do you verify? Well, it says right here, to verify that f of x and g of x are inverse functions of each other, simply do both g of x inside f of x, and then do f of x inside g of x, and both should equal x. Okay? So, if we go back down here, on number 4, I need to take, and let's do the notation. I want to plug in g of x inside f of x. So instead of f of x, I'm going to have f of g of x. So I'm going to plug in g of x inside f of x. So what does f of x look like? Well, f of x looks like x plus 2. So I'm going to write it as x plus 2. But notice that I put parentheses instead of x. And I'm going to take the g of x function and plug it in inside the parentheses. So the g of x function is x minus 2. So the question is, are these inverses of each other? Yes, they are. Why? Because the -2 and the +2 cancel out, which just leaves you with x. So far so good. When I plug in g of x into my f of x function, I just get x. All I need to do now is do the other way around. Plug in my f of x inside my g of x. Okay? So I want to take my g of x function, but instead of x, I want to put f of x in there. That's the correct notation. I hope that makes sense to you guys. So what does this notation tell me to do? To take my f of x function and plug it inside my g of x function. So I need to take my f of x and plug it inside my g of x. So a good thing to do would be to rewrite my g of x function, but instead of x, put parentheses. So I'm going to put equals parentheses -2, and I'm going to plug in my f of x function in there. My f of x function is x plus 2. And as you could see, when I work this out, the +2 and the -2 cancel out, and I truly just get x. So I have verified that both f of x and g of x are truly inverse functions of each other. Why? Because when I plug one into the other, I get x, and then when I switch it up and plug in the other one into the other one, I get x also. And that's how we verify inverse functions, by plugging them into each other and getting x as an answer. Okay, let's try number 5. And again, it's always good to understand notation. I'm going to do f of x, but instead of me putting an x right here, what I'm going to do is put g of x in there. And this notation is telling me that I want to take my f of x function, which is equal to 2 parentheses plus 3, because instead of x I put parentheses, and I want to take my g of x function and plug it into that parenthesis. So I will have 1/2 x minus 3 halves. Is everybody with me? Yeah. I'm going to distribute 2 times 1/2, and what's that going to leave me? 2 times 1/2 x. What does that leave me? 1x. How about 2 times -3 halves x? Or -3 halves. What does that leave me? A -3, because the 2 and the 2 in the denominator cancel out. You just have a -3 left over. And let's not forget about the +3 that's on the outside. And once again, when you combine like terms, you truly just get x as an answer. So we have verified that they are inverse functions, but we still need to do it the other way around, plugging in f of x into g of x. So to do that, I want to do g, but instead of x, I want to put f of x right here. And that's saying that I'm going to plug in my f of x into my g of x. So my g of x, my g of x function is 1/2, but instead of x I put parentheses, minus 3 halves. And I want to take my f of x function, which is 2x plus 3, and plug this in to the parenthesis. So that's going to be 2x plus 3. And when I distribute, I will have just x, because 1/2 times 2 is just 1. And then 1/2 times 3, that's going to be a positive 3 halves. And let's not forget about the outside -3 halves. So once again, the positive 3 halves and the -3 halves truly do cancel out, and we do get x as an answer. So we have verified that f of x and g of x are truly inverse functions of each other. So I think this last one, actually we're out of time on this video. I won't be able to upload it, so I hope this helps. One thing I do want to mention, guys, is number 6. If you try to plug in f of x into g of x, it's not going to work. You're not just going to get x. You'll see that these guys are not inverse functions of each other.